Thank you. So we've been talking about lines and segments, right? So a segment means it's got a starting point and an ending point, right? And a line would go on forever and ever. So we're talking today just about a segment. So there's going to be a starting point, and that point is called your initial point. And then you've got an ending point as well, right? So a starting point and an ending point. Great. Normally when you're working with segment AB, it does not matter which one we start with. So remember last week we were talking about how to name a line segment. You could go backwards and forwards. You could say line segment AB, or you could say BA. It didn't matter. Well, with a partition, a directed line segment means whichever one comes first when you're naming it is going to be your starting point, your initial point, and then the second letter is going to be your ending point. So you do have to go in order based upon what direction is given to you. Okay, so partitioning a segment into a 2-3 ratio implies that if you start at point A at the beginning here, the ratio of 2 to 3 indicates the segment will be divided into 5 equal sections. So a ratio is just taking like the whole segment and we're breaking it down into smaller pieces. Okay, so it's like piece to piece is what a ratio is. You're talking about one piece of the segment to another piece of the segment. If P is the partition point, it will be located 2 of the equal sections away from A and 3 of the equal sections away from B. Consequently, P will be closer to A than it will be to B, since A is the initial point. Notice how in the examples below, all situations start from point A. So we've got 4 different pictures here that are actually showing the same thing. Point P partitions AB in a ratio of 2 to 3. So that's this first picture here. So point A is my starting point, right? That's my initial point. This is where I start. And my ending point is going to be that point B. So start at A, end at B. This is your ending point. And P is the partition point. It's the point that divides the segment up into smaller pieces. So if I say it has a ratio of 2 to 3, that means from A to P, there's 2 pieces. And then from P to B, there are 3 pieces. In total, that's 5 pieces, right? You've got piece to piece in total, 2 plus 3 gives you 5 pieces in total. So a ratio of 2 to 3 has a fraction of 2/5. You're 2/5 of the way to the end of the segment. Same thing if I went the other way. If point P partitions AB in a ratio of 3 to 2, that means 3 pieces to 2 pieces. In total, how many pieces do you have? You had 3 and then 2. You've got 5 pieces in total, exactly. So when I give it to you as a ratio, I'm going to kind of just do it right below here. A ratio means you're going from piece to piece. So ratio is talking about pieces of the whole. A fraction, right? So if I say it's 2/5 of the way from the beginning to the end, that means it's how many pieces out of the total amount. So it's a piece out of the whole total segment. Piece out of the whole. Okay, so let's do an example before we get to our actual equation here. If I gave you the ratio, let's say 3/5, that means 3 pieces to 5 pieces. What would that be as a fraction? 8, exactly. It would be 3 pieces out of the 8. So 3/5 as a ratio is 3/8 as a fraction. Good. What if I gave you 7 to 9 as your ratio? What would that be as a fraction? It would be out of 16. So it's 7 out of 16. Good. Let's do one more. What if it's not bad, right? What if I gave you the fraction of 4/9? How would I go backwards? What would that be as a ratio? 4 to 5. Very good. So 4 pieces to 5 pieces. In total, that is 9 pieces. Good. So in order to find a partition point on a graph, right, finding the point that divides up your segment into smaller pieces, here is what our equation is going to look like. You're going to do both the x and the y coordinates. You're going to have to do it twice, once for the x's, one for the y's, just like how we did before with like midpoint, right? You have to find x's and y's. Here's what your equation looks like. You will take the partition point minus the first point, then the last point minus the partition point, and it must equal your ratio. So if I give it to you as a ratio, you can leave it that way. If I give it to you as a fraction, you are going to have to change it to be a ratio. It must be a ratio. It cannot be a fraction. That's really important. Otherwise, you're not going to get the right answer. It has to be a ratio. All right, so let's take a look at our steps and let's do some examples. So we've got a couple steps and we're going to follow these steps every single time we do a partition problem. Step 1, we are always going to draw a picture no matter what. And when we draw our picture, we're going to put our initial point or our starting point on the left and then label our points as we go. So your starting point is always on the left, just like you're reading a book, okay, from left to right. If you are given a fraction, you must rewrite it as a ratio. That's second step. Third step, we're going to make 2 proportions or 2 fractions. One for the x values, one for the y values. And then we're going to cross multiply and solve for our x, cross multiply and solve for our y, just like we did in our warm-up. So let's do an example number 1. It says, find the coordinate of point P that lies along the directed line segment from A to B and partitions the segments in a ratio of 3 to 2. Okay, so step 1, we're going to draw a picture. Let's start there. Don't draw it too big. Okay, here's my line segment. What is my initial or starting point? 3, 4. So A is my starting point. Good. And what's my ending point, my last point? B is my end point. Good. Okay, so right underneath the A and the B, I'm just going to label the points. So point A is 3, 4. And point B is 6, 10. Okay. Point P is somewhere along that line between the 2 points, and it partitions the segment in a ratio 3 pieces to 2 pieces. So is that partition point going to be closer to A or closer to B? If it's 3 pieces to 2 pieces, it's going to be closer to B, right? Because this should be bigger. It's a 3 pieces. So I'm going to put my P just closer over here to my B value. That's my partition point. It's dividing up my segment. And I don't know the coordinates of it, so I'm just going to write X and Y because I don't know what those pieces are yet. I don't know what those coordinates are. Okay, and it is your problem given to you as a ratio. Do you need to rewrite it? Is it a ratio or a fraction? What did I give you? I gave you a ratio, so you're good to go. You don't have to change anything. So the ratio is 3 to 2, and I put it right above my picture here. There's my ratio, 3 to 2. Okay, we're going to label our points, and then we'll actually get started on the actual plugging into the equation. So this was my first point, right? My starting point, my initial point. Point B is my last point. And point P is my partition point. And it's going to be really helpful to have them labeled, because once they're labeled, now I can just plug the numbers into the equation. So the equation that I gave you, that you're going to have to memorize, was partition point minus the first, last minus partition is equal to the ratio. You have to do both the X and the Y coordinates individually. So I'm going to start with the X coordinates. It doesn't matter which one you start with, but I'm going to start with the X's. Now, let's circle all of our X coordinates. Which one's your X coordinate in point A?
3.
The 3. Obviously, the X is your X coordinate. And which one's the X coordinate in your B?
6.
The 6. Good. Okay. So here's how it works. The equation says you take the partition point and you subtract the first point. So my partition point is X. So I start with X. Minus my first point is 3. Partition point minus my first point over last point minus partition point. So my last point is 6 minus my partition point is X. So there's my first fraction. And I'm going to set this equal to the ratio. What is your ratio? 3 to 2. So I've got my 3. And now I've got my 2. This now should look like what we did for our warm-up. Right, so it's 2 fractions. I've got an equal sign between them, so I can cross multiply. So what are going to be the first 2 that I'm going to multiply together here? 6 minus X times 3. It's a full equation, so you have to multiply the whole equation by that number. So I'm going to take this 3, I'm going to write it first. And then in parentheses, I'm going to put my equation, which is 6 minus X. Okay, that's one side of the equation. What does the other side of the equation look like? X minus 3 times 2. Good. I'm just going to put the 2 first just to make my life easy. And the reason I did that is because I have to distribute. So if I put it first, it just makes it a little cleaner, a little nicer to look at. All right, and now this is just an algebra problem. So we've got a number in front of the parentheses, so we have to distribute it. What is 3 times 6? What? It's 18. What is 3 times negative X? Negative 3X. And then I do the same on the right. 2 times X is 2X. 2 times negative 3 is negative 6. Okay, now I want to get all my X's, to one side, and it's always easier to move the smaller X. So which one should I move? That's not the smaller one. Yeah, this is a negative 3. If you move that one, it'll make your life easy. Then you don't have to deal with negative numbers. So I'm going to add 3X on both sides. Working from left to right, I've got 18 equals 5X minus 6. Great. What comes next? Add 6. I get 24 equals 5X. And then what's your final step? Divide by 5. And you're going to get a decimal, and that's okay because you're allowed to graph decimals. I don't know what that is off the top of my head. 4 point something, 4.7, 4 point. What is it? 4.8. Okay. So your X value is 4.8. Whew. Unfortunately, I'm not done. Oh my gosh, why am I not done? Well, I don't have to plug in. I'm trying to find the coordinates of a point, like on a. So what's the other thing you need to plot a point on a graph? I need the Y. Oh man, I've only done the X so far. I also have to do the Y now, which means I have to do the same thing a second time. Because all of this work just gave me the X coordinate of the point on the graph. I still have to get the Y coordinate because right now all you know is how far to go over on the X axis. You don't know which way to go up or down on the Y axis. So I have to do it a second time. Hooray! Are you so excited? Don't all look so happy. All right, we're going to do the Y values. Same thing. Now, it's the same setup. It is partition point minus the first over last minus partition. Who can set up our equation for us? So you're looking only at the blues now. Only at the blues, yep. Partition minus first. So Y minus. Good. You're good. Y minus 4 over. Yep. Y again. Equals, which is 3 over 2. Yep. Yeah, it's a fraction. A ratio is just a fraction. 3 over 2. Ta-da! It's the same thing. A second time. Okay. I think you can try this part on your own. Oh, yes, I believe in you. It's algebra. Give it a go. And if you get a decimal, that's okay. You're allowed to graph decimals. So I'm going to give you about a minute and a half here. Give that one a try. All right, take a look at yours and check your work with mine. Does it look the same. Yeah, no, there you go. Good, good, good. So the one part you have to be careful of when you're doing partitioning, not only is making sure you plug your numbers into the right equation, like in the right order, but it's also making sure when you multiply and you do your cross multiplying that you multiply your ratio times the entire thing, which means you're always going to have to do some kind of distribution. So make sure you're distributing to both the first and the second number, because if you forget to distribute, you're not going to get the right answer. Okay, so make sure you're distributing your answer to both pieces in the parentheses. When we write our final answer, because this is a coordinate point, it's point P, my final answer I want to write as a coordinate. So point P is, X value goes first, 4.8, comma, and then my Y value is 7.6. And for partitioning, like I said before, it's okay to get decimals. You're allowed to graph decimals. They don't have to be perfect numbers to graph them. So you're going to get a lot of decimals. Don't freak out. All right, what questions can I answer right now? All right, let's do one more. Let's do number 2, and then we'll be done. Okay. All right, number 2. It says, find the coordinates of point P that lies along the directed line segment from A to B. Point P is the partition point and is located 1/5 of the segment length. 1/5. Okay, so we're going to start just like before. We're going to draw a picture. We're going to make sure we always draw a picture every single time. That's always step 1. Okay, what is your starting point? Which point goes on the left? Okay, what's my ending point? What goes all the way on the right? B. So A is 1, 1, and B is 7, 3. So this is my first point, and this is my last point. Okay, so that was step 1. Step 2, if you're given a fraction, you must rewrite it as a ratio. Was I given a fraction or a ratio for this problem? I'm given a fraction of 1/5. Now remember, that means one piece to the whole 5 parts. So if you were to rewrite that as a ratio, piece to piece, what does that look like? 1/4. Very nice. So as a, do I have small? I should put it as a ratio, it is 1/4. So if you're thinking about 1 to 4 pieces, should point P be closer to A or should it be closer to B? Should be closer to A. Good. Doesn't have to be exact, obviously. Okay, and I don't know what my partition point is, so I'm putting XY. I'm just going to put the word part there to write the whole thing. And my ratio is 1/4. Okay, so let's just set up the 2 equations and then you'll finish them on your own. So we'll just write the equations to start. Okay, so my X coordinates are all the ones that come first. The 1, the X, and the 7. Who can set up my equation for me? Who wants to give it a try? Partition point minus the first over last minus partition. Who wants to give it a try? I'm going to pause you there. Partition minus the first.
Oh, X minus 1.
There you go. Over. Over last minus partition is what?
7 minus 6.
And then I set that equal to my ratio, which is what? Oh, careful. That's 1/4 is my ratio. Because 1/5 is the total length. That's a fraction. So you're saying 1 out of 5 pieces in total, that would be 1 piece to 4 pieces. Because in total, that gives you the 5 pieces. Oh. So my ratio is 1 to 4. Okay, there's my X's. Let's set up the Y's, and then you've got some homework for tonight. Oh my gosh, Mr. Massa making us do math homework, math class. Oh, crazy. All right, what would my Y's be? Same setup. Partition minus first is what? Summer, thanks for making eye contact. What is it? Mm-hmm. Over. And what do I set that equal to? 1/4. Perfect. And then you've got a little bit of cross multiplying to do. All right, here's your homework tonight, friends. You are going to do, you're going to finish up number 2. You're going to do 2, 3, and 4. Okay, that's your homework tonight. Number 2, number 3, and number 4. And we are going to check them tomorrow. Two, 3, and 4. From what? Really? Uh-huh. Were you spelling my name right?
I did your first name.
I don't know. I don't know. I will check. I don't know why that happened.